Now we are moving on to the next presentation by Roberto Parisi from the University of Salerno, but also the Blue Marble Space Institute of Science. I guess you have participated in the same program as Ignacy?
Yes, in the same project. Hello.
Perfect, perfect. So he is going to be talking about the drugs for skin radioprotection in space missions. So something that we have just discussed, well, not for the skin, but in general, just discussed a little bit. So perfect. Please start. I will let you know when there will be kind of designed time for your presentation will be over. So we will have still 5 minutes for the quickly wrapping up and allowing some time for discussion.
Okay, cool. Okay, so good morning. My name is Roberto, and I'm an undergraduate student at the University of Salerno and also a visiting scholar at the Blue Marble Space Institute of Science. And this presentation is about something that we have worked during the last 2 years, and is mainly finding some particular countermeasures to the exposure to uranium radiation during long-term space missions. And we started studying different chemical compounds, but this presentation is mainly focused on particular chemical substances that we can find in food, in order not to give a lot of drugs to astronauts, but mainly shaping their diets in order to get the same results. So the first slide is just introductory and is about the space radiation. So we have a lot of electromagnetic waves that build up the space radiation that we can encounter in the deep space. And as you can see from this image on the right, there are many sources when astronauts are in a space mission, and many of them can be very dangerous to the human health. So a first way to approach this problem, that is in fact, as discussed by many articles in literature, still the biggest biological limitation. One way is the shielding that is mainly linked to the engineering side. So maybe creating some particular technologies that can avoid interaction between the human body and this particular kind of radiation. But also we can think about working on the biological side. And this is what we are mainly focusing right now, thanks to this different approach to diets. So when it comes to space radiation, as I said, there are many different kinds of wavelengths inside. And this presentation is mainly based on the ultraviolet light that is in fact encountered not only in space, but also on Earth. So there is this double, let's say, advantage that we can think about. And the UV light, so I just made this slide with some important information. In fact, you can see that it's just a group of particular electromagnetic waves that have a wavelength that is usually shorter than 400 nanometers. And it has today many applications, like, for example, disinfection, especially food disinfection. In fact, often food is basically radiated with UV light, and then it kills all the bacteria that are present inside. But also it is usually used in medicine for the management of these diseases like acne and atopic dermatitis. It has been demonstrated, in fact, that this particular kind of light is able to upregulate the activity of T regulatory cells in the lymphocyte system. And so it allows the creation of an immunogenic tolerance towards the inflammation that is, for example, causing the atopic dermatitis. When it comes to the description, the UV light, we have another subdivision into these three groups. The UVA are the ones with the longest wavelength, and for this reason, they're able to penetrate the skin in the deepest layers. Then we have the UVB that are transmitting through the atmosphere, but they just reach the outermost layers of our skin. And then we have the UVC that are usually shielded thanks to the ozone layer on the Earth. But we have to take this into account since we're talking about space missions, because we don't have the same kind of protection in the atmosphere in deep space missions. This last slide that is introductory does explain what is the relationship between the exposure to UV light and the human skin and some particular pathologies. So why we are searching for a solution. And you can see this is probably the most important bullet point, that the prolonged exposure to UV light is a health risk for the onset of skin cancer. We don't have just one kind of skin cancer, the melanoma, that is probably the most famous and known one, but we have also a subset of particular cancers that are called an MSC, that are the non-melanomic skin cancer. And we have these two important representatives that are basal cell carcinoma and the squamous cell carcinoma that can be very dangerous. And you can see that there is also a different pattern of penetration. UVA are the deepest ones, and then we have UVB. So the UVB have mainly an effect here, while the UVA can also cause a genetic burden of mutation, making to the fact that this kind of radiation has the sufficient energy to cause breaks into the DNA, and so they can lead to mutation and then are linked to the onset of skin cancer. So with this introduction, we move now to the second section of the presentation, that are the analysis of three important groups of chemical compounds that can be interesting for their radioprotection, and so the protection against the photooxidative stress that is caused by UV radiation in the space missions. First one is the flavonoids. What are flavonoids? Flavonoids are these particular polyphenolic compounds that are usually foundable in vegetables and fruits. And you can see that they all have the same basic structure, that is these two benzene rings that are linking together thanks to this pyrene ring in the middle. And there are many different classes of these compounds that are different based on the pattern of substitution, and also, the oxidation, so with the presence of particular groups that we're going to analyze in the next slides. So, as I was saying, the level of oxidation not only is able to differentiate the different classes of these compounds, but also the hydroxyl groups are responsible for the antioxidant properties of these substances. And we have a very important advantage with these compounds because, as you can see, their low solubility and also the short intestinal residency kind of avoids the fact that they can, accumulate in our body and so lead to particular problems, especially in the gastrointestinal tract. There is this very interesting article that we have taken into account that is kind of old. It's probably in the early 2000. It's 2000, and it was written in Italy, I guess, by many Italian researchers, and it basically shows the interaction between the human skin and these particular compounds after the radiation with UV light. And the three compounds are these ones. So you can see that there is always the basic structure, and what changes basically the pattern of oxidation on the pyrene group in the middle. And here you can see that there is an extra hydroxyl group that will make the difference, as we're going to see in the next slide. So they just took these skin samples from breast reduction operation. And then, since we are just interested in analyzing what happens in the keratinocytes, that are the cells that make up the epidermis, they just eliminated all the fat that is in the basal structure. Going back, they just eliminated the dermis and hypodermis, and they just kept this part that is in fact called the SCE samples. That means stratus corneum plus epidermis. And they evaluated the antioxidant properties thanks to this particular assay that analyzes this compound that is mainly generated after lipid peroxidation. And you can see that that hydroxyl group that I was talking about makes the difference, because among all the three, this substance, that is the quercetin, has the strongest anti-radical property, because this group can stabilize some particular radicals. And these two compounds are very important because they show a higher percutaneous absorption, because, as we said, the exposure to ionizing radiation, especially ultraviolet, does not only limit itself to the outermost layers, but also goes in the deep. So we have to find some particular substances that can reach the same deepness in order to protect the deepest layers. So when it comes to the anti-radical properties, the quercetin was the best candidate. But when it comes to the percutaneous absorption, these two were the most important ones. Also, there was an evidence of spectral changes, which means that they not only are able to stabilize the radicals, but they're also able to absorb UV light. So as if it was a sunscreen that we use, for example, when you go to the beach. Then we have the second group of substances, that is the hydroxycyanic acids. And these substances have a very complicated structure, the phenolic compounds. And you can see here what happens when they are basically ingested through the mouth. So we have the ingestion, it reaches the gastrointestinal tract. There are these particular enzymes that lead to the separation from the plant structure, so the plant polysaccharides. Then the active principle is then metabolized by the microflora. There is the absorbent, and then there are particular enzymes that activate these compounds into active metabolites, thanks to the glucuronidation and the sulfuration. And these are the two most important representatives that are very common also in our diets, like the caffeic acid and the ferulic acid. They have just some particular changes here in this particular structure. It's called the catechol moiety. And you can see also here that the presence of these hydroxyl groups are responsible for the anti-radical properties. So the caffeic acid has this particular catechol moiety that is mainly based on the orthodihydroxyl group that is present on this benzene ring. While here in the ferulic acid, we have this particular structure here that is then, substituted except for the hydrogen. We have this methyl group here. And there was another important article that analyzed the importance of these substances. And basically, in this project, they applicated topically the substance in order to analyze their importance against the photooxidative skin stress. And also they analyzed the nitric oxide, because there is another way of creating radicals, not only through oxygen, so the ROS, but also some particular radicals that arise from the nitric oxide. That is neurotransmitter, is very important in our body. And the scan samples were obtained with the same preparation, so breast reduction operation plus the trimming of the fat, leading to the creation of these particular samples. And what were the results? The results were that caffeic acid and ferulic acid showed to have this antioxidant activity against also the nitric oxide radicals. So this was the first evidence literature. And also they're able to inhibit the propagation of the lipid peroxidation, thanks always to the MDA assay, thanks to the presence of those hydroxyl groups that we saw before. And here you can see that the ferulic acid has better properties when it comes to the absorption, but also the permeation through the skin for the UVA light that reaches the deepest layers. But the caffeic acid, if you remember the thing that we were saying about the quantity of hydroxyl groups, has the biggest anti-radical property, because here we can find two of them, while here we have just one. Then we have the last substance that we have analyzed, that is curcumin. And curcumin has probably the most complicated of all that we have seen until now. And it is a biphenolic active compound that is foundable in this particular vegetable, this is the turmeric. And you can see that there is this particular structure that we haven't seen before that acts like an electron donor. And for this reason, donating electrons to unstable species, like, for example, the radicals, lead to their stabilization. And so it blocks those peroxidation processes that we can find in the membranes, and that can lead to cell damage. So thanks to its properties, the mesh classified this as an NSAID, that is a non-steroidal anti-inflammatory drug. And you can see that it shows all the characteristic properties of an anti-inflammatory agent. And since it has more oxygen groups than the alpha-tocopherol, that is a particular vitamin that is used also in the antioxidant therapies, it can be more soluble in solvents like water. So, for example, if we have to prepare some beverages for the astronauts during space missions, we can provide the curcumin rather than the alpha-tocopherol, because there is a better solubility, and for this reason can be, for example, mixed with water in the beverages that they can bring on board. And this is another important experiment that they did, coming from this article, that explains the protection that was evidenced against radiotherapy-induced oxidative injury. In this case, we don't have the UV light, but we have this source that comes from cobalt-60. There were these mice, and the distance between the source and the mice were about 1 meter. And they evaluated the effect of curcumin after radiation, and there were these 4 particular groups. There were the control group, so no radiation and curcumin. The group 2 that was just radiation. Third one was just the curcumin, so just the treatment. And the fourth one was the most important one. It showed, in fact, the application of radiation and also curcumin. And the results were, since it's an antioxidant substance, we have also a reduction of the MDA levels, which means that there is an anti-radical property. Then we have a reversion.
5 minutes.
Okay. A reversion of enzymes like the C80 and the superoxide dehydrogenase. And you can see that also there is an anti-inflammatory property leading to the downregulation of these particular genes that we can find in many inflammations. Like, for example, this was the inducible nitric oxide synthase. And this might be synergic with the effect of the hydroxycinnamic acid that we have seen before that can scavenge also the radicals coming from the nitric oxide, and also the lipoxygenases and cyclooxygenases that are linked to the synthesis of prostaglandins and other inflammatory substances. So the curcumin effect has both radioprotection, radiosensibilization. Radioprotection because of all this that we have said, but also radiosensibilization because it upregulates all the genes that are linked to apoptosis. So instead of causing the survival that might create a burden that then leads to the transformation into a cancerous cell, the curcumin, when it sees that a cell is damaged, let's say that it promotes the death of that cell. So it also prevents the cancer indirectly. So this is the conclusive slide that is mainly what we are doing right now. So we are trying to reshaping the Osterholz diets, considering all the different sources of the substances that we have discussed until now. And we are planning on doing this, considering all the caloric intake and all the substances that Osterholz need during their space mission, but adding particular food in order to create a new kind of intake of all these antioxidant substances. And this is mainly due to the fact that, as I said before, we don't want to create a burden of drugs that astronauts should take in order to have the same effects. Also because we have also taken into account the drug-drug interaction in pharmacology. And so food might represent a viable way to give the same products, but in a different and also viable way, so reshaping basically their nutrition. And this was the last slide. So I thank you for the attention. And if you need anything else, maybe explain, there is my mail.
Perfect. Thank you very much for this very interesting and quite optimistic presentation, I would say, to be according to what I understood from your last slide. We need to drink a lot of wine and some tea and plums that I also love, and mix it all with curry. It will be fine. So I like that. And we have some questions from Ignace. Do you think that pharmacological countermeasures can ever be more effective than passive shielding against radiation? That's a good question.
Sadly, considering the state of art right now, I don't think so. Because basically in the last decades, especially during the space programs like the Mercury or the Apollo ones, we had a very important, sprint over the engineering side. So there were very important technologies that have been developed that can be very effective against the radiation. And I guess that this part of the pharmacology is just the beginning because it has been explored as much as the engineering side. So for the moment, I guess that the passive shielding represents still the most important source that we have to protect astronauts. But probably in the future, when we also are able to discover new synthetic molecules, we're able to improve their situation, giving them drugs or in fact food and other substances.
Cool. And like how useful right now is because you talked about the influence of different particles that can help with the exposure to radiation, but how big of a change does it realistically provide? Like if they will, how much of curry they need to consume in order to stay safe, let's say? Or, is there any amount of curry that would help,
Well,
like, measurably?
well, the fact is that we know that all these compounds that I talk about are present in food, but we know that the food that they consume in space is not the same that we have here. So they also have dried or maybe under vacuum substances. So maybe a viable way is extracting these compounds from the food and maybe adding them, like, for example, vitamin tablets or something like that. For example, let's speak about the turmeric. That is the most important source for the curcumin. It's quite, let's say, utopistic that the astronauts will bring with them the curry powder, as I showed in the in the slides.
Yeah,
But
I can see problems with that in space.
but they can basically extract on the ground the principle, the drug, just the curcumin, and then maybe I don't know, they can create, for example, some tablets that they can use or they can dissolve, for example, in water on board, so avoiding to bring the whole food, let's say.
Cool. Okay, thank you very much for this very interesting talk. And if you have any further question, please ask them directly to Roberto.